I want to show you, here we go, we're recording. I want to show you Desmos. Shout out to Ben for reminding me last class about Desmos. And I figured out how to do a piecewise on Desmos. So this is Desmos. If you type in desmos.com, here, I'll actually just do it for you. Desmos.com. Surely the site. It'll come up like with this screen. And then if you click graphing calculator, it'll come up to this screen. And I wasn't sure how to do a piecewise on Desmos, but honestly, the piecewise on Desmos is actually pretty nice. It's a little bit nicer, I hate to say it, than my TI calculator, which I love because I'm very familiar with the calculator. Been doing it so long. So I'm going to do the same piecewise. I'm going to do the 3 function one. And it's really easy. You just type Y. I mean, actually, there's a keyboard right down here on the bottom left. And you can type the Y. But you type Y. Each of the pieces, you type Y equals. And then let's say it's the X plus 1 line. And that's a beautiful X plus 1 line. But let's say we only want a piece of it. So you know normally there would be a comma and an X and a less than symbol and whatnot. Well, you have to put squiggle brackets. That's how I found out. So if you only wanted it restrict it for X less than or equal to 2. So you type squiggle bracket X less than or equal to 2. And then close the squiggle bracket. Look at there. You got that piece right there. Let's say you have now the middle piece. You would type Y equals 3. And then the squiggle bracket for this one was 2 is less than X is less than or equal to 4. 2 is less than X is less than or equal to 4. And look at that. It just graphed it right in. Now in the TI-80 or 83 calculator, this is much more difficult if you remember to type. We had to go divide, parenthesis. We had to write actually 2 equations here. We had to write an X is greater than 2 and an X is less than or equal to 4. And so I was impressed with this. And then this one, negative 2X plus 7. Oh, look at that. I don't even need to type Y equals. I'm learning something new every day. And let's bracket it off for X is greater than 4. And close the squiggle bracket. Move this up. So look at that. And then you can also like press your cursor on it and it'll give you a point. Like, look, it says 2 undefined on the blue. It should be defined on the red. It should be closed. Over here, 4, 3. This one is 4 undefined. Like it actually tells you if it's a open or closed like that. And I just think that was pretty neat. It draws your piece for you. I think it's really easy to do. And again, you're allowed to use this on the test and type it all in right here on Desmos. I do want to do one more for you. So let me get rid of this. So squiggle brackets help. I'm going to do the greatest integer function, which I found on here. So we're going to do Y equals. If you go to this word functions right here inside the keyboard and you go over to miscellaneous, it says the word floor. The greatest integer function is also called a floor function or a step function. Depends on like what book you're talking about. But if you do floor X, look at that. And then I'll just close my parenthesis. There's your step function right there. And then if you want to do like Y equals, let's say 2 times the greatest integer function, which is floor x, and then we'll do +5, something like that. Look, now it's shifted it. And remember, the trick was you draw 2x plus 5 line, and then you create your open circle, closed circle, all the way up, or closed open, excuse me. But I think that was, I think that's pretty neat. And again, you can kind of put your cursor there. It's not really doing the open and close part for you. This would be closed right here, and this would be open, but it will move it right to the next step. So that's the only kind of trick of it all, but still pretty neat. So I wanted to show that with you today. So if you want to play around with Desmos, I think it's kind of a neat thing. So thank you, Ben, for showing me that again. I appreciate it. All right, so let's get going on to today's one and only lesson. But like I said, a lot going on. This is lesson 2.6. Operations and composition of function. Operations and compositions of functions. Okay. So on everything you learn in mathematics, you have operations. When you first learn to numbers, you learn to add and subtract and multiply and divide. When you first learn about fractions, you add, subtract, multiply, and divide. I mean, all the way on up. Then you learn about polynomials and you add, subtract, and divide. Well, same idea is with functions. So we are going to just have to look at some notation. So the sum of two functions can be written like this: f plus g of x, which means you take the f of x and you add it to the g of x. Okay, that sounds pretty simple. But notice the difference in notations. These mean the same thing. They might write it like this. You need to realize that it means this. You take your f function and you add it to your g function. There's a difference. F minus g of x. And that would be f of x minus g of x. Easy. There's also a product. Fg of x. Sometimes they put a dot in between. It depends. But that means f of x times g of x. And then last but not least is the quotient, where you have f over the g of x, which is your f of x function divided by your g of x function. Okay, so let's go over an example that you could have, that I saw you have at first. They're going to give you an f of x function, x squared plus 1. And then they're going to give you a g of x function, 3x plus 5. And they're going to ask you some questions. My son is being very loud tonight. Excuse me while I scream his name. Judah! You're loud. Thanks. Sheesh. This child. F plus g of 1. F minus g of 3. Fg of 5. And f over the g of 0. So we're going to do all of these. So here's what they're asking. They're saying, okay, I want you to find the f plus the g of 1. So the easiest way to do it, especially when they give you a number, I mean, if they didn't give you this number, you'd have to actually, add the polynomials together. But if they give you the number, what they're asking for is the f of 1 plus the g of 1. So that means you're going to take 1 and you're going to plug it into the f function. 1 squared for x. 1 squared plus 1 is 2. So this is 2. Then you're going to take 1 and plug it into the g. 1 times 3 is 3 plus 5 is 8. And then you just add them together. 2 and 8 make 10. Simple. F plus g of 1 is 10. Let's do f minus g of 3. So again, that's the same thing as saying the f of 3 minus the g of 3. So again, we're going to plug a 3 into the f. 3 squared is 9. 9 plus 1 is 10. So this is 10. We're going to plug a 3 into the g. 3 times 3 is 9. 9 plus 5 is 14. So 10 minus 14, negative 4. How about f times g? F times g of 5. So you would do the f of 5 times the g of 5. So plug 5 in. You get 25 because it's 5 squared plus 1. 25 plus 1 is 26. And now plug 5 in for g. 5 times 3 is 15. 15 plus 5 is 20. And now multiply those two answers out together. 520. All right, one more here. So plug in 0. This would be the f of 0 over the g of 0. So 0 squared plus 1 is 1. 0 times 3 is 0 plus 5 is 5. 1/5. So that's basic operations of functions. Pretty simple. But now we're going to do another example where we don't have numbers. We have to just write out the simplified form of f plus g of x. Okay, so let me do an example of that. They're going to give you given f of x equals 8x minus 9 and g of x equals the square root of 2x minus 1. And they're going to ask for the f plus the g of x, the f minus the g of x, the g of x, and the f over the g of x. They're also going to ask you for the domain. So I want to kind of talk to you about the domain of these first, okay? First things first, for these, the plus, the minus, and the multiplication, it's the overlap. Your domains are I shouldn't say domain are, the domain is the overlap of f and g. And I'll show you what that means in a minute, okay? But when you have a fraction, your domain is the overlap, but it's also where the bottom can't be 0. Because remember, when you have a fraction, you can't have that bottom, you can't have that g of x right now being 0. So your domain is the overlap and where bottom can't be 0. Okay, so be aware of this when you do the work. Now, I want to actually first look at both of these and find their domain and kind of put it up here for me so that when we talk about each one, it'll make more sense. So this is a line, all lines, all parabolas, anything with degree 3, whatever. All of those have a domain of all reals. So your domain for this one is pretty much the whole number line, negative infinity to infinity. X can be anything I want it to be. But the domain for a square root is different. If you remember, square root is that like it curves over to the right. You can't take the square root of a negative. You can take the square root of 0, but you can't take the square root of anything below 0. So what you do is you set this underneath the square root greater than or equal to 0. And if you solve this, if you solve for 2x minus 1 is greater than or equal to 0, you get 2x is greater than or equal to 1. X is greater than or equal to 1/2. So your domain would be, x can be anything above or equal to 1/2. If we wrote it in notation, greater than or equal to 1/2. So it would be with the bracket. Now that's going to change a little bit, and we'll talk about this in relationship to adding, subtracting, and multiplying the s. But the domain is important. We've talked about domain before being very heavy in this whole entire course, so you're going to have to understand this. All right, so let's do f plus the g of x. So what am I asking for? I'm asking for the f of x function, and I want you to add it to the g of x function. So take your f of x, 8x minus 9, and you're going to add it to this g of x. Now, if this didn't have the square root symbol, you could just add the 8x and the 2x and call it 10x and combine like terms, but there's no like terms to combine. So this is really your answer. Now let's talk about the domain here. The domain for the f of x, again, was the whole entire number line. So if you're thinking about, here's a number line, the domain for my f of x would be this whole entire line. But the domain for the g of x function can only be values of x that are greater than or equal to 1/2. So where are those two graphs overlapping? Well, are they not overlapping right here, right at this one right here, for all values at 1/2 to infinity? So the domain for this one would be 1/2 to infinity, because that's the overlap for f plus g. That's overlapping, meaning the red line and the blue line, where do they both share the same answers? All right, let's do f minus g. F minus g of x would be, again, f of x minus g of x. So I take 8x minus 9 minus the square root of 2x minus 1. And again, if these were like terms and I could combine them, I would, but I can't. Now, what is their domain? Their domain is still this one. They all share the same domain if it's plus, minus, or multiplication. They're all sharing that same domain. F times g of x would be f of x times g of x. So the only thing different I would do here is I'd probably put the 8x minus 9 in a parenthesis and then put the square root of 2x minus 1 in its own parenthesis. And again, if this didn't have a square root and it just had 2x minus 1, you'd have to FOIL it out. But this is what they have, and there's nothing more you can do here. And again, their overlap it's still the 1/2 to infinity. All right, now this last one, f over the g of x. So this is the f of x over the g of x, which would be 8x minus 9 over the square root of 2x minus 1. Okay, now, here's the problem with this one. Their overlap would be fine, but it's not just the overlap. It's also where the bottom cannot equal 0. This bottom cannot be 0. But Mrs. Seta, you just said up here that it can be greater than or equal to 0. Yes, if it was not in a bottom. But if it's in a bottom, then this right here can only be greater than 0 because you don't want it to equal 0. So 2x minus 1 is just greater than 0. 2x is greater than 1, x is greater than 1/2. So my domain now changes. It's no longer equal to the 1/2. My domain can only be 1/2 to infinity. Okay, so that's the difference. These all are overlapping right here. These three can be equal to the 1/2 because they're allowed to be zeros. This one, because it's in a bottom, can't be equal to 0. So I just have to change that bracket to a parenthesis. Hopefully that made a little bit of sense. Let's do one more of those. Not all of it, but just one more that's kind of similar. Let's let f of x be the square root of x plus 5. And g of x equals 1 over x minus 1. And I want you to find f minus g of x and its domain. All right, so again, f minus the g of x is the overlap of these two, but where the bottom, you don't want that bottom to be 0, so that's going to be a problem there. So we'll do this in a minute. So let's talk about this guy's domain. Again, if you're under a square root, you are allowed to be greater than or equal to 0. Okay? If you're in the bottom and you're in a denominator and you're under a square root, you can only be greater than 0 because you can't equal it. So this would be x is greater than or equal to -5. That would be the domain. If I were to write that out with interval notation, x being greater than or equal to 5 would be, excuse me, then -5 would be like that, from -5 to infinity, positive. This one, what's the domain restriction here? Well, I don't want this to ever be 0. When's the only time that's going to be 0? Well, when x equals 1. So I don't want it to be 1. That would be my domain. So now let's put these two functions together with a subtraction sign. So let's do f minus g of x, which is equal to f of x minus g of x. So I take my square root of x plus 5 minus 1 over x minus 1. That's a minus 1. And again, nothing really to simplify here. You can leave this alone. But let's talk about its domain. So again, the domain for f of x function, it's this guy right here. If I were graphing it on a number line, I would go to -5 all the way to infinity, like that way. with a bracket. But the g of x says, no, wait a second, you can't be a 1. So that means there's like, here at 1, there's a hole in my graph. So how do I write this in interval notation? We'll take it piece by piece, take it from the lowest to the next lowest to the next lowest. If I were to write this domain, I would say, okay, my domain for these two functions combined would be from -5 up until, oh, I have a problem at 1. Since it's open, I put a parenthesis. So this section right here is -5 to 1. United with, now how do I write this section? Well, that would be 1, still open, because I'm not allowed to equal it, all the way to infinity. This would be the domain of these two functions joined together. That's where they overlap. All right, so lots of information there, but I tried to, again, what I try to do is I try to pick problems that you're going to see similarly on your homework. And if you're confused, by all means, stay after. I can go over them again, or we can work on some of the problems together. Now I want to evaluate from a graph. This is important. We do this a lot in calculus, and I saw that this was also on your homework. Evaluate from a graph. All right, now gonna have to give me a minute to draw this out, because I want to be accurate. You'll see why. 1, 2, 3, 4, 5. And they're going to give you this. Let's see. 1. I think this is the point. Yes, 1, 3. And that one. And so they're going to have this line right here. Oops. And this they're going to call the y equals f of x line. And then I'm going to do my g of x in a different color. And this is the y equals g of x line. Okay. And they're going to ask you to find from the graph, we'll do 2 examples of these, the f plus the g of 1, and then the f over the g of 0. Okay, so similarly to what we've done before, again, what we had was an equation. Now we have to read it off of a graph. Don't forget, f of x is just a fancy notation for a y value. G of x is just a fancy notation for a y value. The f of x is the y on the blue line, whereas the g of x is the y value on the red line. Okay? So when I write this out, I'm saying I want the f of 1 plus the g of 1. Again, this 1 is the x value. I want you to tell me the f of 1. I want you to tell me the y value on which color. Well, if I want the f of 1, I would go to 1 on the x, and I want the f function, the f function's y. So if I go up here, that right there is 1 on the x. What would be its y value? 3. Let's do that again for G. Again, now I want G of X, my X being 1, and I want to go this time to the red line. G, here's 1, and I want to go to my red line. What would be my Y value there? It would be 1. And now just add those two Y values together. 3 plus 1 is 4. Okay, let's do this again for this one. F over G of 0. Again, if I were writing this out, this would be the F of 0 over the G of 0. So I now want to go to the 0 on the X, and I want to go to the blue line, and I want you to tell me what the Y value is. The Y value would be 1. Now I want to go to the 0 on the X, and I want you to tell me what the red line's Y value is. Well, that is right here, right at the origin. So that point is 0. So what is 1 over 0? Well, that's undefined. We can't divide by 0, so that would just be your undefined. So that's how you evaluate from a graph. You go to your x-axis, go up to the graph, and then tell me what the y value is. X-axis, go up to the graph, tell me what the y value is. And that's how you would evaluate it. And then you add those two y's, or you divide those two y's, or you multiply those two y's. So pretty easy, most people like the visual parts. Here's how you would evaluate from a table. Some people like tables better. So they'll give you an x, an f of x, and a g of x, and they're going to give you a table, -2, 0, 2, 4, and then they're going to give you a bunch of numbers here. 5, 1, 5, 17. Okay, and then they'll say, okay, find the f minus the g of -2. And then let's see if we can do another one. Find the FG of 2. Let's see if that works. I'm just picking one up. F minus the G of -2. Again, that means the F of -2 minus the G of -2. So the F of -2. So go to -2 on your X and tell me what it is, what its Y value is in the F function. That would be a 5. That's my Y value. Now I want to go to -2 on the X and tell me what the G function is. -2, the G function is 4. And now subtract them. Your answer would be 1. All right, we'll do another one. F times G of 2. So that's the F of 2 times the G of 2. So go to the 2 on the X and tell me what it is in the F function. Well, that would be 5. Now go to the 2 in the G. So here's 2 again, but in the G function, the Y value is -4. And now just multiply those two together. -20. So evaluating from a graph and evaluating from a table are really, really super easy. Okay. Difference quotient. Oh, this is fun. Look at that. It's already 6:40, but I told you this is a beefy one. Still have a few more things to go through. This is really important. Very important, especially for those of you who are thinking about going to calculus. We do the difference quotient right away in calculus, probably within the first week that you'll take it. This is super important, and you will see this for sure on a test. The difference quotient. So if I were to, here's where it comes from. If I were to draw a curve, and I asked you to find the slope of this curve of the secant line. If you don't know, remember what a secant line is. The secant line is a line that cuts through it at 2 points, this point and this point. Okay, and let's call this point X. Then we would label this coordinate as X, comma, f of X. Let's go a certain distance away and let's call it H distance away. So then this point right here would be X plus H units away. Then this coordinate would be the X plus H coordinate, and the f of X plus H would be the Y value. Now, if I asked you to now find the slope of this red line, which is known as the secant, you all know slope. Slope is y2 minus y1. So f of X plus H minus f of X over x2 minus x1. X plus H minus X. Oops. When you clean this up, you would get the top would remain the same, but the bottom, the X's would cancel, and you'd be left with H. This right here, f of X plus H minus f of X all over H, is known as the difference quotient. Very, very important. And we're going to spend 2 examples doing this. And these examples, like I said, very algebra-esque. So you're going to be asked to find the difference quotient of f of X equals X squared plus 1. Okay? And I'm going to try to break this down for you because this gets really difficult even with my calculus students. They still struggle on this. But here's what you do, okay? So you need 3 things to this equation. You need to find the f of X plus H, the f of X, which they should already give you, and then you subtract them and put it over H. And then you do a little bit of algebra to simplify it, okay? So we'll start with find the f of X plus H. Now, what does that really mean? Well, it means wherever you see an X, you put in to the function X plus H. You put, wherever you see an X right here, you're going to instead put an X plus H right there. So you're rewriting this function with an X plus H. If this was a 5, you'd put a 5. Well, if it's an X plus H, you put an X plus H right there. So this would be X plus H squared plus 1. Now, you got to clean it up. Sorry, it's just part of the lovely part of the difference quotient. X plus h squared means x plus h times x plus h. So you got to FOIL it out. And that would be x squared plus 2xh plus h squared. And then don't forget you have plus 1. Put a box around that. Put a box around that. That right there is f of x plus h. Now that you've done that, you're going to plug this in. So we'll say this is step 2. You're going to plug this in. Plug into the difference quotient. Okay, now again, what is the difference quotient? I have it written up here, but I'm going to write it again. The difference quotient says, take your f of x plus h, which you just found. Let me use some highlighters here. We love colors, right? Take your f of x plus h, which is this right here. Subtract it from your f of x, which is, isn't that your f of x? So you're going to subtract that. And then you're going to put all of that over h and clean it up. Okay, so in my orange highlighter, instead of f of x plus h, I'm going to replace it with this. I'm going to replace it with x squared plus 2xh plus h squared plus 1. F of x, I'm going to replace it with my green equation. So I'm going to write minus parentheses, that's important because we're going to have to distribute, x squared plus 1. So that right there is my f of x. That right there is my f of x plus h that I just found. And then the whole thing goes over h. And I go to clean it up. So I'm going to distribute that negative, which would be negative x squared minus 1. And look what cancels. Let's see. The x squared goes bye-bye. The positive 1 and the negative 1 go bye-bye. So all I have is 2xh plus an h squared divided by h. Can that clean up any further? Sure, you can get rid of an h. So you would be left with 2x plus 1h. And that is the difference quotient for this function right here. Now again, I know you're like, who cares? Why are we doing this? But this is such a huge, huge concept in calculus. And I know for sure it will be tested again on you. All right, I want to do one more of those, one more difficult one. And then we'll do composition. And then I think we're almost done. I told you, this is it. This is a beefy lesson. But we're doing good. We got through it. Find the difference quotient of f of x equals 1 over 6x. This one no one likes, but meh. We'll do it first. Okay, so rule number 1, find your f of x plus h. What does that mean again? That means everywhere there's an x, you're going to just replace it with x plus h. Okay, so I'm going to rewrite this as 1 over 6 and not put x, put x plus h. And then you can even go 1 over 6x plus 6h. You can leave it like that. Okay, that right there is your x plus h. All right, now we're going to plug things into the formula. Okay, so we've got my orange f of x plus h. This is right here, my f of x. So number 2, the formula and I always write it again. I'm going to write it again anyway. It says f of x plus h minus your f of x all over your h. And I'm starting with highlighters because I think it helps people see what to plug in. All right, so I'm going to put this right here into the orange box. So 1 over 6x plus 6h. This green goes into that green box. 1 over 6x. And then the whole thing's over h. Now, you would think, oh, can I just be done? No. You have to, unfortunately, find common denominators and clean this up, which is probably the worst part of this problem. The algebra part is the worst part of this problem. Okay, so we'll start here. These is two fractions within a fraction. We need to make this whole top one fraction. This goes all the way back to stuff that you learned in algebra. So you need to find a common denominator, which in this case would be both of them. So my common denominator would be, well, actually, I probably could leave this factored. Yeah, let me do that. Let me leave this as 1 over 6 times x plus h minus 1 over 6x. Okay. So my common denominator would be that I need them both to have a 6, which they have. I need them both to have an x and an x plus h to have that whole entire denominator bottom. So let me move right here. So this is just the top. I need a 6, x, and an x plus h. I need these two fractions to have this denominator, if you remember doing that in algebra. So what is this bottom missing? Well, it's missing an x, so I'm going to need to times that top by an x. What's this bottom missing? It's missing an x plus h, so I'm going to need to times this top by x plus h. And notice there's a subtraction, so I want to distribute that. So it would be minus x minus h. And that becomes important because look what goes away. Bye-bye. Now remember, this is all over h. So now I have on top negative h over 6x times x plus h, all divided by h. Now I don't know how your teacher taught you back in the day, but how do you have a fraction when you have a fraction over another number or fraction over fraction? They may have said something like same change flip. And so that's what we're going to do right here. We're going to keep the top the same. We're going to change this division symbol right here to multiplication. And we're going to flip the h to be 1 over h. And now you can cross cancel. And your final answer would be negative 1 over 6x times x plus h. That right there is the difference quotient for that guy. And it is painful, but it's got a lot of algebra and everything that we've done encapsulated in this question. And like I said, you'll have 2 of these questions to do. So kind of, again, I'm recording this so you can go back over and kind of slow down, like, how did she get this? I had to find a common denominator. You might not remember how to do that, but it's very important that you find a common denominator and then simplify it all the way down to negative 1 divided by 6x times x plus h. Okay, I'm not done, but I'm going to give us a quick 10-minute break. I've got 4 more pages here that I'm doing, fog and Goff stuff, and just some cost, revenue, profit that I saw in the homework. And then I want to go over the quiz with you, and then we'll be done.